Good morning, everyone. My name is Mario Albarracin, student of the Biotechnology Fast Track program of Centennial College. My experiment topic is the anti-oxidation effects of ascorbic acid addition on the surface of cut apples. My hypothesis is the addition of ascorbic acid to cut apples in high concentrations delay browning oxidation and show a reduction of superficial pH compared to the concentration of this acid present naturally. The reason for this experiment is that cut fruits are processed in industries or sold in stores, and those fruits need to stay in good condition for this to be carried out. Oxidized fruits have lost a big part of their organoleptic qualities, resulting in a deterioration of flavors and odors. Therefore, fruits become rancid. Oxidation also affects the nutrient content, like vitamin, when these are exposed to oxygen. The use of antioxidants can help to delay this natural but unfavorable process. The pH, which is one of my dependent variables, were measured with pH strips and a scale included in the package. The brand is Indigo Instruments. The brand of the vitamin C supplement I consider for this experiment is Atoma, which comes in a presentation of 500 milligrams per tablet of ascorbic acid. These tablets were crushed using a mortar and in a pestle. Well, my procedure was taking a sample of 20 grams of the commercial ascorbic acid supplement. This sample were measured using an analytic balance. This analytic balance was one of the Centennial College ones. Then I prepared three different solutions. One solution was of 0.001 molar, the second was 0.004 molar, and the third was 0.006 molar. Those three solutions were made using 0.18 grams, 0.70 grams, and 1.06 grams of the previously pulverized ascorbic acid. All those solutions using 1 liter of filtered tap water. And the pH were measured along the time. For the first 30 minutes were measured every 5 minutes. And after the first 30 minutes of the experiment, the pH was taken every 30 minutes until 4 hours and 30 minutes of the experiment were completed. Along with the three solutions, 2 controls were carried out. Negative control using just water alone, in the positive control using a high concentrated solution of 0.1 molar using 1 liter of water as well. All the solutions were made in plastic containers, which were previously labeled. The 1 liter of water for each of the solutions were measured using a measuring jar. And here are presented the solutions once were already made. Here's my positive control, and here's my negative control, which didn't have any kind of ascorbic acid added. After the solutions were prepared, I proceed to cut the apple slices using a ruler, and all the initial pH of the samples of the apple slices itself were measured, and the initial pH of those slices were 4. We dipped into the solution and left them for 5 minutes until they get soaked. The purpose of this is that the solutions and the acid get into the slices, so the pH of the slices itself changes along the time. After that, the slices were taken out and put on top different plates which were previously labeled. The 3 of the solutions were carried out at the same time, along with the 2 controls, as observed. The environmental conditions, the temperature of the room was set up in 25 Celsius degrees, which is the temperature set up in the thermostat. Let's go to the results. The results are presented in this table, in this first table, which is the pH measurement listed solutions for the different solutions, which I carried out in my experiment along with the 2 controls. The first solution is 0.01 molar, the second is the 0.004 molar, the third is the 0.006 molar, and obviously the positive control is 0.1 molar. I observe that when the concentration is lower, the pH increases. It take more for the pH to increase, but not only that, as well as the pH is more stable along the time. We can observe that in the positive control, which the pH not only didn't go that high as the others, but it is more stable. The pH didn't change that much. And the negative control, the pH changed a lot, going up and going down along the time. But in the least concentrated one solution, the pH was increased, but was increasingly, the concentration increased along the time, but at an unstable pace. But as the concentration increased, we can observe that the pH kept low as well. At the end of the experiment, the pH was very high, which is not favorable for antioxidation conditions. But as the pH increased, as the concentration increased, the pH kept lower, which is favorable for the antioxidation of cut apples. And this figure, which is a graph, I can observe the trend of the different solutions along with the 2 controls I had. The one in yellow is the positive control, which is the more stable one, but and the other, which is the negative control, which is the light blue line, which is this one. The pH tended to vary a lot. Sometimes it went down, others went up. And at the end of the experiment, most of the solutions tended to be very, very high and around the pH of 6. As my second dependent variable, which was the color, I observed that the color of the opposite lysis changed along the time, but the same case is here, which is related to the pH. We observed that along the time, the foods tended to go darker. And when the experiment finished, almost every slice, all the slices were very dark. But the positive control, which is the most concentrated one, kept very bright no matter the pass of the time. And the negative control was the darkest one. And I'm gonna look at the solutions, which is the 0.006 molar was less dark than the less concentrated solution. And the least concentrated solution, which was 0.001 molar, was the darkest solution at the end of the experiment.